regional I'm a regional math coordinator out of Spokane, Washington at ESD 101. And I'd like to welcome you to a session that Linda invited me to host on Math Fact Fluency. I did a session last fall, and I'll be building on that session. It won't be necessary that you attended that session, but it might be that there's a few things we're not digging into as deeply tonight, but building onto. Please, there's 11 of us total in this meeting right now. If you have a question, either post it in the chat or please feel free to unmute yourself and just ask your question, because with a small group, it's like having a small classroom. We want this to be a place where you can do that. Oh, and I should start sharing my screen, don't you think? And I'm sorry, I know that takes over your screen, but I'm going to do that because I need to, because you need to be able to see the slide deck that I'm using. So let me just get it presenting here so that you don't have to see it ugly. So welcome, this is our second session. And just to be very clear, I want you to know that this session, most of it is based on the work that you see on that image right on your screen. Math Fact Fluency, 60+ games and assessment tools to support learning and retention. And that's an important bit for me to call out. So, as we do often, I'd like to acknowledge that I am coming from the traditional lands of the Colville Confederated Tribes, and you might see it right up here. It's a huge kind of golden chunk right here. And one of the reasons that I love that we call this out now is our Indigenous friends and neighbors really put forth the notion of 7th generational thinking and decision making. And what that's really all about is the decisions that we make and the work that we do today should really positively impact 7 generations into the future. And I think that that's an awesome opportunity and a big responsibility. So I share that with you, and we'll embrace that as we do our learning tonight. So when you're part of a virtual classroom, let's put out a few things, a few norms, if you will, that help us navigate tonight. And that is to acknowledge grace with each other, because we're all at different points in our learning journey. Please name yourself if you haven't already, and if at all possible, use video tonight. Participation is important, active participation. So we will be going to breakout rooms. We'll be utilizing the chat, and there are a couple math games we're going to play. And the last thing that I want to call out is just be willing to think about things maybe differently than you've experienced them before, and be willing to try each of the things tonight and recognize that we're all learners. So one last thing before we start. There are a few core beliefs that myself and other math educators really hold near and dear to our hearts, and we share those straight up. Number one, math competence should never be based solely on how fast a person responds. Number two, we should develop math confidence through perseverance and grit. That's a goal of all teachers. And third and lastly, all math games that we use and we share are centered on mathematics. They provide choice, and they're quick to learn and easy to play. And we believe in learning with math games. Whoops, sorry. Okay, so there's a couple outcomes for tonight. I'm just going to be straight up. We're going to clarify a little bit about fluency for you. We're going to just briefly visit the 5 fundamentals, focusing on 2 specifically for tonight. I'm going to share some math fact progressions. We're going to play a game, and hopefully you get to have a little fun. So with that, we're going to start out by playing a game called Probroken Calculator. And here's the way this game goes. We're going to get our math brains warmed up, and we're only going to take a few minutes to do this. You're going to want a piece of scratch paper, okay? This isn't something you have to do just with mental math. But you'll notice there's a calculator there, and it says the goal is 21. And you'll also notice there are 4 buttons on our calculator covered. And so the goal is to get to 21 in at least one way. But if you get one way, try and see if you can get maybe a second or a third way using the buttons that are available there. So I'm going to quiet myself. I'm going to give you about a minute. Again, be sure and just jot it down on a piece of scratch paper. And I forgot to say this, but you guys are all doing an excellent job of it. Hold your one way that you get it, or your second or third, for just a minute. It leads to a more robust discussion. After a full day of working, no less. So here's what we're going to do now. I have a couple people assisting me with the chat, and I'm going to invite you to do one of two things. You can either give your answer in the chat, or again, since there's only a few of us, I'd invite you to unmute yourself and share your thinking. The reason that I'm saying that is there's less guessing if we can just have a conversation. So what I'm going to do is I've got my next slide ready right here. If I get there we go. And I'm going to annotate on this slide. And so if somebody would be willing to share their thinking, I would love to share your thinking on this slide.
Sure, I will.
Okay, and who's that?
Sam.
Pam? Okay.
Sam, yeah, Sam.
Sorry.
That's
Sam.
okay. That's okay.
Old ears sometimes. Okay,
Hey.
will you explain your thinking to us and see if we can follow along with your reasoning and what your answer?
Sure. One I just put on there was 7 times 3.
Okay, so what I heard you say is you knew that you could get 21 by doing 7 times 3, right?
Correct.
I'm just wondering, Sam, how you knew that 7 times 3 would equal 21.
Because I know my facts.
Okay, because you know your facts. Good enough. Okay, did anybody use a different equation to get 21?
I did.
Okay, Jesse, can you share what you did?
Sure. I did 99 minus 78.
Okay, what I heard you say is you knew that 99 and you were going to subtract 78. And you were thinking that's 21 too, right?
Yes.
So Jesse, how did you know? Did you use a calculator, or what did you do? And this isn't about outing. It's just about sharing our mathematical thinking. So what were you thinking to know that 99 subtract 78 would work?
Well, after 7 times 3, I had to think a little harder.
Oh.
And I saw only the large numbers on the calculator were available.
Okay.
I went to the big numbers first and I was like, oh, I can minus.
Okay, so I got a question for you. Okay, can I ask you a question?
Yeah.
I'm over here on the calculator,
Yeah.
and I see the 9 on the calculator, but I don't see. Oh, you have 78. Sorry,
No,
my bad. See, I just had to think about it, and when I'm facilitating, it's harder to think about it. That's all.
Yeah.
Okay, so you used subtraction. Anybody else do something different?
We have some in the chat.
Okay.
So we have Sarah said 7 plus 7 plus 4 plus 3.
Okay, what I heard you say was 7 plus 7 plus
4.
4 and 3 are there. See, I'm just checking now. 4 plus 3. Okay.
And then she also said 6 times 3 plus 3. Yeah, right. Equals 21. Sorry, I let you finish that.
That's right. No. I'm just, okay. And then what was your other one that you said?
6 times 3 plus 3.
6 times 3 plus 3. And now, okay, remind me who this was that said this.
Sarah.
So Sarah, okay, if you're willing to speak up, and you can just say no in the chat and you won't offend me. I see that we used 7 times 3 up at the top, right here. And I'm just wondering how you knew you could do 6 times 3 and add a 3.
Because I guess I knew order of operations. So if I multiply 6 times 3 first and get 18 and then add 3, that would give me 21.
Okay. So that is so interesting to me. And it's just one of the things we call out. Now I want you to notice something that was nuanced. I didn't tell anyone that shared these possibilities. And you know what? There's plenty more. We could go on and on. We could spend a whole hour just on this, but we're going to get to some other things. So I didn't say, oh, that's right. I didn't say it was good. I didn't say I like your answer. And one of the things that we know as math educators is we're backing away from that and we're asking about strategies to call out. And we would do the same no matter if the answer was correct or not, because what we're most interested in is student or learner thinking. And hopefully that will make sense as we go through tonight. So thank you for sharing these with me. There's one quick thing I have to do now. I have to clear all my drawings, and perhaps you all know this. So I've used some annotation tools in Zoom. And if I don't clear them, this writing shows up on the next slide. And I'm just sharing all of those little learner tips. If you're not aware of those, that's awesome. But there you go, in one fell swoop, I do that. And now I'm going to get rid of my annotation tools on another screen and get over here. So thank you for joining in and warming up our math brains. I want to think about fluency because you're all very fluent. You were able to come up with an answer in a very short amount of time. Nobody was talking about counting up on their fingers or counting all, okay? So what I want to call out right here is this is a graphic that you have access to on your HyperDoc, and I'll show you that in just a minute. But on the left-hand side here, it's talking about procedural fluency. And procedural fluency really takes into account those 3 things in the middle: accuracy, efficiency, and flexibility. And accuracy just means that within a reasonable amount of time, we get a correct answer. And a correct answer is important, but it's also important that we select a strategy to get there, that we're not just memorizing our math facts. And then one of the most important things is flexibility. And we haven't thought about that. Often when we ask teachers what's fluency, they'll say it's fast and accurate. Well, that's true. Those 2 things are. But flexibility means I can use that strategy in a context, meaning a story problem, or when I'm given harder or more other numbers, okay? It can be adapted. It also means that if I try strategy and I see it doesn't work, I don't keep at it and keep at it. I think, better try something different. So I just want to call that out before we do 2 things right here. And first of all, we're going to watch a video. It's about 5 minutes in length. This is, and I'm going to escape this right now because I already have this open, I believe. At least I thought I did. I thought I had this open in maybe I didn't. Let me go back. I can do it this way. I'll just quickly speed it up. This is in its entirety. It's a 15-minute video, and we're going to watch just 5 minutes. This, and we're going to have a reading that's paired for a minute, and then we're going to relate that back to how students are learning and how we support them in learning math facts. We're going to play a game. Okay, so I want to be very transparent here. I'll go ahead and click on this, but I'm going to speed it up here to the 2-minute. I would highly suggest, if you have time, going to this video. This is a mathematician out of Idaho. Her name is Christina Tondevold, and she's done an amazing body of work, and she shares some free resources. So if I start this,
an understanding of math fluency for elementary kids. But let's start off this video.
Just one moment. I want to preface this. This is a second video that she has. I can give you the resources to all of the videos. What I'd like you to think about right here, and it's on the slide, is what is something you already knew and something that might be new to you, okay? And again, I'm going to stop this in just about 5 minutes, okay? Think about all learners as she talks through the video.
With how to build fluency with math facts. Now, the first thing I want to start off with is, what is fact fluency? Now, the teachers use the term fluency a lot, but as parents, we tend to look at our kids and say, are they fast or not? And in a prior video, I talked about the difference between these two terms and how we really shouldn't use them interchangeably. Now, that video is linked up inside of the Building Math Fluency Kit, and I also go into a lot more detail about what is fluency and how we build it inside of that kit. So if you want more detail about it, go to the kit. For this one, I just want to do a quick little overview that fluency is not just fast. So if your child seems like they are fast with their math facts, that doesn't necessarily mean that they are fluent. And the other way, even if they're not fast, they can still be on their way to building fluency. Fluency actually has 3 parts. We do want kids to be accurate, get the correct answer, efficient, which means, are they fast? Do they get there fairly quickly? But also a 3rd part, which is, are they flexible? And this is often a piece that is missing for students to be truly fluent. Just because they're fast and they get the right answer doesn't mean that they are fluent in math. They also need to have some flexibility. So what does that actually look like? Here's a little image that I want to share with you, that if we are just focused on getting kids the correct answer, this is really the only connection that we are building for kids. If we are focusing on 6 + 7 = 13, and we are just trying to drill it into them, 6 + 7 is 13. They only have this one connection point that is built. So this idea of building flexibility in our students means helping them to see it in lots of different ways. And the way that that first starts out, which is not where we want them to end, but the place that they first start out is with counting. They do a lot of counting and counting on. A lot of kids might tend to start to see that 7 + 6 is related to 6 + 7, and it eventually gives you that same answer of 13. But we don't want kids to always be falling back to counting. And unfortunately, that's what happens. If you have a kiddo who doesn't instantly know that 6 + 7 is 13, the only other connection point they have is to go back to counting on their fingers, which is what you may see students or your own personal kids do. And it makes you feel like they aren't fluent. And they aren't yet. But how do we get them there besides just learn it, memorize it, know it? So one of the first things that I encourage all of us to do is to use lots of visuals and putting the problem into context. But we'll go into that into more detail in the Building Math Fluency Starter Kit. So the other piece comes in when we start to look at these different strategies, that 6 + 7 is related to 6 + 6 because it's just one more. Or it's also similar to 7 + 7 and you just subtract 1. Or there's kids who like to make 10. So they'll find a way to break apart the numbers and turn one of the numbers into a 10. All of these pieces, we don't want them to have to learn them all, but oftentimes they are kind of taught in isolation, like learn your doubles +1, your doubles +2. But the way that they really build this flexibility is by building in connection points, right? Did you see that? Did you notice the difference? I'll flip back to it here. Here's without it, here's with it. The more connections that we can help our students or our own personal children build, the easier it is for them to recall information. Being able to recall information is different than memorizing. I can memorize something for a short period of time, but to truly be able to recall information, the more connections we have built, the easier it is to recall information of any kind, but especially in mathematics where we have all of these isolated facts. If you think about just the addition facts, that's 121 different facts that kids are supposed to memorize. And if your child is not a great memorizer, it becomes very difficult. And that's just addition. And if you throw on subtraction on top of that, and then as they move into multiplication and division, that's a lot of facts to be memorizing. So instead, I want to give you an alternative about helping your child or your students be able to see types of facts and how they connect together. So
we're going to stop right there because she's highlighted a few things. And I'm going to guess that you've maybe had some things again, and I'm going to stop my share for just a second so I can see the screen with the people. I'm going to guess that in the video, there could be things that you were familiar with, something that you knew, and then there could be something that was new to you. So I'm going to invite people again, because we're a really small group, to unmute themselves and share either something they were familiar with or something that she brought out that might be new.
I'll go. I know that memorizing facts and finding the relations, like knowing your doubles, is something that's a good thing to know. But then that there's a relationship to doubles plus one. If you know 7 plus 7 is 14, then 7 plus 8 is one more. 7 plus 6 is one less. I teach second grade, and I constantly, the ones that don't have them memorized, we talk about any relations, any things that they do know and how it's related so that they can master the fact that they don't have quite.
Not
readily
yet,
available.
right?
Yes. Yeah.
Thanks for sharing. And I want to tell you, Randy, when we get to the part where we're playing a math game, if you want your little mathematician that kind of faded in, she can join us. Okay, just saying, that's fair game in my world. Anybody else?
I'll jump in. I was subbing in 5th grade math today, and it makes sense. I don't think I've ever been able to put the wording to flexibility.
Yes.
Because I for sure would say, yeah, accuracy, efficiency for sure. But then we have kiddos, like when they go to fractions, they might have memorized their multiplication tables, but then when you go to converting fractions in some sort of capacity, you're adding and subtracting, or you're multiplying, dividing, and being able to flex in that. I guess I haven't been able to label what that was, but it's flexing for sure. So
Jesse, you bring up a really important point, and that's going to be shared on a slide in just a minute. What we are doing when we're first learning to count and count on, and then use some of those strategies. And Christy just called out doubles and doubles plus one, but there's other strategies. First, our learners learn those with whole numbers, okay, and small whole numbers, but then they should be able to apply those to multi-digit whole numbers, and then to fractions and decimals and percents, because the same strategies hold true in our system of mathematics. And you know what? You're not alone. A lot of people say, oh my gosh, I knew fast and accurate. I had never thought about how to put that into words, talking about flexibility. So thanks for calling it out. It's not because I want to cut people off. And if you have something really important to say, please say it in the chat. But I want to move us along. And I think in the chat, I put in there, it's really important for you to have access to that interactive agenda. I'm going to share my screen and show you why. We're going to send you to breakout rooms in just a few minutes. Not yet though. And one of the things that we're going to do before we go to breakout rooms is we're going to jigsaw a reading. It's short, but it talks about two things. And let me share my screen first. Should probably do that because talking to you and not sharing doesn't help you know where I am. Let me go back to the slideshow. We just watched Christina Tondevold right here. Okay, and we're going to, I think I have to go on. I think this is going to be a mistake. Pretty sure I just made a mistake. I think I have to go on so it doesn't play the slide because I'm pretty sure Christina would start talking to us again. So her work and fluency really parallels nicely with the book that the work that I'm sharing with you is based on. And when we consider the 5 fundamentals of fact learning and retention. Okay, so the first one being that mastery must focus on fluency. So if we want kids to master their math facts, get so that they are pretty automatic in their responses, and Christina called this out, there's a difference between memorization and recalling from memory, having those strategies that I can use. So she pretty much called that out for us. The second one is fluency develops in 3 phases. And she touched on this in that graphic with connections. We don't want our students to only be able to go back to counting all or counting on. Those 3 phases we're going to talk about in just a minute, but they are counting, deriving, and then mastery. That is fundamental number 2. Fundamental number 3 is foundational facts must precede derived facts. Probably makes sense just using the word foundational and then derived. We'll dig into that in just a minute. Timed tests do not assess fluency is fundamental number 4. There are other ways to assess fluency, but the bottom line is in a timed test, the only evidence you truly have is whether the answer is correct or not. You don't know if a student guessed. You don't know if they really knew it or they were lucky. It was just, you don't know. All you have is it a correct answer or is it not? And there are better ways to do that. And lastly, students need substantial and enjoyable practice. So those are the 5 fundamentals. And now if you go to your interactive agenda, which looks just like this, and I can probably make this quite a bit bigger so you can see it. So this is something that's linked in the chat. This is the interactive agenda, and I'll be able to tell when more of you get there because see this little icon right here? There's going to be more of you right there. And it's going to be important to do that because we are going to chapter 1 right here. And in chapter 1, it is literally chapter 1 of the book that this work is based on. And it talks about fundamental 2 and 3. And if I scroll down, oh, there's that fluency icon. But if I scroll down a little bit further to page 4, it says fundamental 2. Fluency develops in 3 phases. And right after that is fundamental 3. It looks like there's more text here, but that's because there's graphics included. So you are going to have a few minutes and we need to read, and you'll choose to read either fundamental 2 or fundamental 3. And we're going to have about 5 minutes to do that. So I'm going to start my timer, and I'm a little worried right now because I only see one person on here.
It made copies of the agenda.
Pardon me?
It made a copy of the agenda,
Okay.
so it might not show that we're there.
Alrighty.
because I have a copy
Perfect.
of mine. I don't know.
Sorry.
If that's everybody else.
That's awesome if you made a copy of it,
It
because then you
asked us
won't
to.
have it.
Yeah,
Yeah.
it asked us to. So it was
Yeah.
you actually that did it.
Oh,
There you
sorry.
go.
I didn't mean for that to happen. Okay. But awesome that you have it now, because then when you have a copy of it, you'll always have access to this. So I will quiet my voice. I'm going to set a timer for 5 minutes, just skim. And you know what? it would be great if we hopefully have a few people, I've read both, so it won't matter. Go ahead and go to that chapter 1 link. And again, scroll down to page 4 or 5. I have a printer right here, so I printed mine out because I am a hard copy person. But I'm going to quiet my voice so that we can do this, have a quick discussion, and then go to a math game. All right. And here's how you're going to know that 5 minutes are up. I'm going to quiet myself. I'll mute myself. I'll also shut off my camera and I'll turn it back on when 5 minutes is up. Okay. So I know that doesn't allow us, 5 minutes doesn't allow us a deep read, but I'm wondering if there's somebody who would volunteer to give us the 1-minute overview of fundamental number 2, which is fluency develops in 3 phases. If anybody read that. Sam, you're muted still, and I think you might be willing to share.
There you go. Yeah, there you go.
Yeah, there you go.
I
Happens all the
was
time.
saying, really, it just said the counting was the first phase, right? And then the difference between phase 2 and phase 3 was the speed. Like they
Yes.
both have strategies, but that was pretty much the gist of what I got from that little part. So
Yes. And I would tag just one thing on.
Yeah.
Getting to phase 3
Mhm.
and having flexibility is really dependent upon spending enough time in phase 2.
Right, they said they had to
And really-
grapple with phase 2
Yep,
things. Yeah, exactly.
Yep.
Yeah.
And seeing those relationships and those connections. Thanks, Sam.
Absolutely. Yep.
Can anybody, again, I know, and I apologize, we just don't have time to dig into this deeply in 1 hour. What about fundamental 3, that foundational facts must precede derived facts?
I'll jump on.
Go
But
ahead.
the progression was important, and you need to have those foundational facts to get to the derived facts. And so if a kiddo couldn't figure out like 5 + 7, you need to figure out, well, what were the foundational ones they don't know, so you know where to provide intervention for kids. Whether it's multiplication facts or addition facts, there are certain set ones. So you need automaticity of the foundational facts first before you're going to get to derived.
Yes. And that is just so important. And when you think about it and you see those, and I'm going to start sharing my screen again. So we're only looking at these 2 fundamentals, fundamental 2 and 3, although there are 5 of them. And here's the one that we first read about. And thank you for sharing that in phase 1, we count all the objects either mentally or really concretely. Oops, and I should go to here. Sorry, you're seeing the ugly version right there. Okay, so we would be counting all. And then we can get to where we use deriving. So thinking about, we can, for example, in the book, I think it used the example of 5 + 7. If I knew my doubles, which kids tend to learn really quickly, I could say 5 + 5 is 10 and add 2 more. So I'm using the strategy of doubles and adding on, using another strategy that was in that graphic, adding or subtracting 1 or 2 more. And then we get to phase 3 that was just called out, which is mastery. And that's where we have had so much practice that literally as a teacher, we're kind of wondering, okay, did they just memorize that? It can happen so fast once we have those strategies and they've had sufficient time, so they become very automatic. So that's what really great learning of math facts is based on. This I called out and put on the screen because on the left-hand side, that's the graphic that's showing our foundational and derived addition facts. And on the right-hand side is our foundational and derived strategies for multiplication. Again, these are linked on your hyperdoc, but these are really important because I want you to think back to when you learned your math facts. I'm going to guess that most of us learned them by memorizing them. We had flashcards, there was some little computer game in some way, shape, or form. It wasn't really based, for the most part, for most or all of us, on using strategies. And if you look at the top right here, it looks like we start with 2s, 10s, and 5s. So I want to call that out right here. 2s is like knowing our doubles on the left-hand side, way over here in addition. But the difference is here, I'm thinking multiplicatively. I'm thinking of 2 groups of something. And that's a switch for our learners. And that starts at the end of second grade anymore. But those 2s have to be down before I can go to, follow the arrow down here, double a double, which means 4s and 6s and 8s. So that's, sorry about that. My mouse gets a little touchy. That's calling out the importance of really getting solid in those foundational fact sets before we go in derived fact sets. And all of this can be done, again, through the use of games. And Christina would talk about that as well. This is a slide I'm not going to spend much time on because I already prefaced this just a little bit. On the left-hand side, it's talking about some strategies that you saw on the last graphic of making a 10, pretend a 10. These were with whole numbers. And that can be extended into, I talked about multi-digit numbers, because when I have these strategies down with small single digit or very small under 20 2-digit numbers, then I can apply those when I'm comfortable with them to larger numbers. And the person who talked about subbing in 5th grade math today, I can do that when I'm looking at fractions and or decimals. I'm going to assume that many of you work with students at all ages, so those same strategies apply no matter how high our students go in their math. So it's time to play a game. We're going to play a game called Squares Bingo. You're going to be sent to breakout rooms. So one of the things that you're going to want to do right now is you can choose whether to have a driver. We're going to have breakout rooms of about 4, because one person can be the driver, like I am right here. If I click on this game board link, you have it on your HyperDoc or that interactive agenda. When I go here, it takes me to a slide deck. I wish we were in a room together, and I have little cards, bingo cards, squares bingo cards, but I can't do that with you. What I can do is have you join me on this link, and I'm going to put this in the chat. And the reason I'm going to put this in the chat is I want all of you on the same slide deck. I don't want you to go to your own copy. So I'm going to put that right here. Sorry. And there you go. It's in the chat. Let's all get on the same slide deck. There's a reason for that. And while you're doing that, let me share my screen again. Oh, you're there. And you can see that because right up here, it's populated. So I'm going to go to the bottom slide. This is what I always do when I have, when we're demonstrating something. And I'm just going to call out, hey, Sam, would you be willing to be my partner for a minute so we can show them how to play the game?
Yep.
Awesome. So I'm on slide 20, and I'm going to make this Sam right here. And Sam, here's what we're going to do.
Okay.
Our directions are underneath on all the slides. So if you get to a breakout room and you can't remember what we're doing, we're just going to show you how to get started. You can always go to the directions. Sam, we need this slide deck. And another thing that we need is we need this dice thing going on right here. So I just got it, the dice up, and notice what I'm doing on my screen. Now I'm clicking on where it says dice at the top, and I'm dragging it to the left because I'm going to get the dice open for my friend Sam and I, and whoever else ends up in our room. And Sam, it says that we throw a dice. Oh, let's see right here. It says 1 10-sided die. So the first thing I'm going to do is I'm going to go over here on the right and see this dice. I have to go down to a 10-sided die, which is the light blue die. Now I've done that. Okay, I have a virtual die and we have our game boards. So Sam, I'll go first, okay, and I'm going to throw the die. Oh, and I got a 3, it looks like. So it says that then what I do is this is called Squares Bingo because we know something about square numbers. It's the number times itself. Okay, so I've made a light year leap here. This is the rules for the game. And remember, they're right here. So Sam, I know that 3 times 3 is 9. Mm-hmm. And my game board is on the right. So I'm going to grab a yellow and I'm going to see if there's a 9, and there is, and I only see, oh, wait a minute, there's 2 9s. So I have to decide which one. Sam, I've just populated it and I've got mine right there. So I'm going to throw for you. And or I'll throw, but if you have this open, you can move your die. You got a 5.
Okay. So I have 225, so I guess the bottom one. So are you
You
thinking that
choose.
can I do that on my
Yes.
screen? Oh,
Pick it up
okay.
and move it
Well,
if you want.
because-
And if you can't, I can move it for you, Sam.
No, I think I can.
Okay.
Am I doing it? No? Is it working on your screen?
I don't see it.
See,
But
that's what I
here.
said. I'm doing it on the one that I opened.
Okay,
but
so
don't
let me
see it
just
on
move
yours.
it right there. It would look like
Okay.
this. Now, here's the goal of the game. You would want to get 5, either vertical, horizontal, or diagonal.
Okay.
Okay, so you're going to go to a breakout room and you're going to give this a try. We're going to, and I'm going to stop my share. It looks like there's 11 people. So let's have 2 breakout rooms. And I believe you're going to get an invite right now, and you can just talk through it, your strategy and what you want to move. I will tell you something, because of time today, we pre-populated the board, but there are options. If you, once we play it, after you play it once, you could not pre-populate the board and give kids more choices. So go ahead and go to your breakout rooms and give it a try. You two are welcome to go to a breakout room.
I wanted to make sure that you and I weren't in the same one. So,
I won't go. I'll stay here because we have
Okay.
plenty of people that can talk it through. But if you go to one breakout room, Linda, I'll look and I'll just listen in the other breakout room.
okay, I'll go into room 1.
Okay.
Okay.
And Annie, if you want to see how they do this, you're welcome to. You don't have to, though.
Okay. Sorry. Can I join? Oh, I can pick what breakout room I go into, right?
You
Like,
can. Why don't you go ahead and go join room 2, and then
Okay.
I can run the breakout room from here, and I'll call them back in just about like 6 minutes. And I'm literally watching on the slide deck to see them get going.
Okay. Okay. Thank you.
Mhm. Okay, so breakout rooms. We're going to close breakout rooms.
And apparently we started recording when I left the breakout room.
I think when one of us is here, it starts the recording, but it only records here. It does not record breakout rooms.
Right. So anyway, I didn't
all right.
realize that.
Yeah, I'm just closing the breakout rooms because we need to come back, ask
Yeah.
what they noticed. How does that relate to, foundational facts first? This is not a foundational fact game. This would be added on. Anyway, we'll just ask that question
Mhm.
and wrap up.
Okay.
Welcome back. So how did the game go? I didn't, you know what? I don't have to ask. Oh, you guys cleared your game board. Did you?
We didn't. I don't think we did.
No. I didn't.
That's why I said I was on the wrong slide, which is why you couldn't see mine before.
That's okay. Okay, so I made a mistake. And usually what I do when I send people to breakout rooms, I say, if you're in breakout room 1, go to slide 1. If you're breakout 2, go to slide 2.
That's what it
Makes
was.
sense, right,
Okay.
ladies?
Yeah.
But I forgot to give that direction. So it's like wherever they ended up. So one breakout room is on slide 18 and the other one, it looks like is maybe on slide 13.
See, were we
And
18 or I don't know, maybe were we 19?
Well, let me show you how I know, because this is something if you're ever going to do an electronic version of this game, which you have linked on your HyperDoc. Okay, so here's the slide deck. When I put this in grid view, it doesn't matter how many breakout rooms, I can follow the progress just by clicking on the slides.
Yeah.
I can see if there's a group having trouble getting going so you can jump into that breakout room. It's no different than walking by a table group of kids and seeing who's been able to get started and who hasn't. So that's one of the things you want to know about if you're going to do this. But I have a question for you. What did you find in the game?
Well, I was just talking about how you could adapt. We were all talking about how you could adapt it to other things. You know, obviously we use squares for this, but you could use this same game to work
Yes.
on other stuff, which we really liked. So.
Yes. There's even one competition. Again, Sam, it's in the book. It's not like I don't get a kickback from these people, but this is one of my, I have to have it books. This is a 1 hour, just barely dipping your toe in the pond of a 15 clock hour course that I do with somebody else where we dig into this much more robustly. And if you remember, we talked about earlier that fundamental number 3 was that foundational facts had to precede derived facts. And excuse me, if we were to go back to that visual, square numbers is a derived fact because foundational facts are 2s, 10s, and 5s. There's a reason for that. Doubling, thinking about doubles additively really translates nicely to multiplying by 2s. 10s, kids tend to learn because they all end in 0, and 5s, again, they learn skip counting because of their work with a clock and many other things. So it's just something that they learn easily. Anybody else? Anything that they noticed with the game?
I
I'm
thought kids would
excited
have
to
fun
have-
also. I don't know, Christy, go ahead, Christy.
I'm excited to have Lainey in class next year. She's already a whiz at multiplication, first grader, knowing some of her multiplication facts.
Well, we have some practicing to do. Apparently on the spot, she's not that great. So we'll have to, we
That's
need
okay.
an audience.
That's okay. And remember this, remember, we all start out with counting first, and then it's thinking about those strategies. of, make a 10, pretend a 10, and we didn't dig into those deeply before we get to mastery. I just want to share with you one last thing before we go, and I want to honor your time and be done on time because we are at the end. First of all, if you have any questions, so we played the game. If you have any questions, stay on, because I can stay on for a few minutes, or you can always contact me if you have questions. On that HyperDoc or that interactive agenda, there's literally links to tonight's slide deck, to Broken Calculators, how to play that. The directions are there. It doesn't come from the book. It comes from another place called Math for Love. This is a link on Amazon to the book. Here's chapter 1 that you used tonight. And I would highly suggest that book. It's just really great. Here's the link to the specific video we used tonight. And here's a link to a handout that talks about those 5 fundamentals and those 2 graphics that talked about addition, fact progression, and multiplication fact progression. If you wanted to play squares bingo, it is right here. And here's the copy of how you could play it. And then there's a couple variations, and somebody already talked about this. The cool thing about that game is there are so many variations, so you could use it. The other thing is you're back in person. You don't have to do this electronically. And there's a place where a lot of this has been created, and I will link that here. And I really should have showed you this earlier. It's the Kentucky Math website. I'm going to just go there really quick because this is worth you knowing about. And I'm sorry I don't have it linked right yet. A lot of resources for this book are right here on this site. And if I go to right down here, Math Fact Fluency resources, I click on this wherever it lets me click, Math Fact Fluency site. Right here are some games that are already created out of this book. And so when I go to games, it tells me what operation it supports. And squares bingo is right here. So if I click on that, literally I can get a PDF or a Word document with this, and even a Jamboard that's already created. I will link this on that interactive agenda tonight. And with that, I want to thank you for being here after a long day of teaching. And if you have any other questions, please feel free to reach out to me. And other than that, unless there's questions, please interrupt me right now and say, I've got a question. Otherwise, have a good evening.
Thank you.
You're very welcome. Thanks for coming.
Thank you, Deborah.
You're very welcome. And thank you for your help.
Oh,
Both
you're
of you
welcome.
with running the chat, and
And you have lots of thank yous coming through the chat.
it's always fun. In an hour, it goes so free. I mean, you
Yes.
feel like you're doing the drive-by where you're just,
Yeah.
I tried not to fire hose them. I tried to
Right.
make it just.
Yeah. No, I think
That's
it was great. And when I went in that